Hello students, this is lesson 2 in our unit 3 polynomial functions unit. We are going to be talking about in behavior and what we call multiplicity, and this covers notes pages 3 through 5. Questions: what is multiplicity and what does multiplicity do? And I'm going to just tell you what to write here, and then as we go through this it'll become more clear. So multiplicity is the number of times a factor appears. In other words, the degree of the factor. And we're going to look at these in factored form. Not in standard form, but we'll talk about standard form too. What does multiplicity do? It determines whether the function will pass, bounce, or curve at the x-axis. Again, you're not supposed to know what that means right now. I'm hoping you will see the patterns and be able to tell as we go through this. So at the top of page 3, you've got these two boxes, and I want you to fill in these two functions the way I have them up here at the top. And they're very similar, but you see you've got an x minus 1 and x minus 3 in each one. But in this one, on the left, x minus 1 has a degree of 1, because of course there's no exponent written here, so we can just, it's given that it's a 1 here and a 1 here. So these factors each show up 1 time, and these factors show up 2 times and 3 times. In other words, that's just what the exponent is, and that's what the degree is. So let's look at some of these questions that they're asking us, and we can do this from with our previous knowledge. This first one, look at the first function. Is the a value positive or negative? Well, 2 is the a value. This one again is in factored form, so it shows our x-intercepts. If it was in standard form, it would still have a 2 as the leading coefficient, and that's what we're looking at. The a is the leading coefficient, so it is positive, so we'll just write positive here, and you can abbreviate that. What's the degree of the function? What you want to do is you want to add the exponents together. Okay, so when it's in factored form, just add the exponents together. So the degree here is 2. It's a degree of 2. Now, I'm going to make this bigger. This is actually the picture of this graph. I went over to Desmos and I graphed it. Okay, so there we go. And of course, it would have arrows at the end of it. I'm not going to draw them, but it would have arrows. It's just a screenshot right here. So as x values approach the left of the graph, so this right here is in behavior that they're asking us about. As x values approach the left of the graph, so this is the left side. Now what that means is as x approaches negative infinity, what does y do? So this is going to the left and then also up. So as x is approaching negative infinity, y is approaching positive infinity. So that's what they're asking us. You may put the word increasing. I would rather you put approaching positive infinity. Okay, as x values approach the right of the graph, in other words, as x values approach positive infinity, what do the y values do? The y values are going up still. So both sides of them, the y values are going toward positive infinity. So you can write approaching. You can use, remember that arrow we used? You can use that, just whatever you need to do. In previous lessons, I've used the words increasing and decreasing, but I think we really need to use in behavior terms here. So, okay, what are the x-intercepts here? Well, they're shown right here. Okay, but also if you look up here at the factors, of course, we can figure out what the x-intercepts are. And I want you to remember the word x-intercept, roots, zeros, they're all the same thing. Okay, so what are the x-intercepts? Well, there's one at 1 and there's one at 3. So we'll just say that there's an x-intercept at 1, 0 and at 3, 0. Okay, when they ask what happens at these x-intercepts, what this means is, what is the line doing? Well, what it does is it passes right through the x-axis. So what we would say is at 1, 0, we're just going to draw a little arrow here. We're going to say it passes or pass, okay? And then at 3, 0, it does the same thing. The line just passes right through at 3, 0. So we'll just draw a little arrow there and write pass as well. Okay, so now I've brought up the graph of this function that we have on the right. So this one right here. This time we have the x-intercept of 1 with a 2 exponent, and the 3 has a 3 exponent. So let's look at the differences in this one and the one we just did. Okay, is the a value positive or negative? The a value is exactly the same as it was before, so it's positive. Okay, what is the degree of the function? Add the exponents together. 2 plus 3, it's 5. The degree is 5. As x values approach the left of the graph, in other words, as x approaches negative infinity, what does y do? So as x approaches negative infinity, here's my left side right here, so it's going this way. What is y doing? Y values are approaching negative infinity. As x values approach positive infinity, y values are also approaching positive infinity. The x-intercepts are exactly the same as they were before. The thing is they don't pass through. Remember how before it just passed right through the x-axis? This time it does what we call bounce. So at the 1, let's put an arrow here and write the word bounce. You can imagine that like this is a wall, the x-axis is a wall, and you've thrown a basketball against the wall and it bounces and comes back. Okay, so at the 3, it does pass through, but it makes a little turn before it passes through. And we call this a curve. Now, these are not technical math terms. They are not official math terms. They are just descriptions. You might see on an exam, you might see the word squiggle instead of curve. It's just, I think it looks like a curve. It looks like it kind of makes a turn before it keeps going. So that's why I call it a curve. So far we've looked at 2 different functions, equations in factored form, and they have the exact same x-intercepts or roots, but they do different things. The behavior is different at the x-intercepts in this one and the x-intercepts in this one. So I want you to just think about that and start to notice maybe the pattern there. This is our next function on page 3. This is actually number 1. The first 2 were kind of introductory. This one, I went ahead and filled in the a value is positive. It's 0.5. The degree is 4. You just add the 2 plus 2. I put arrows on this one, and I've got a sketch or a screenshot here. You can make a little sketch if you think that would help you. Let's look at in behavior. Okay, again, if you have trouble with this, draw your arrows. So we're moving to the left here. X is moving left and y is moving up. This is negative, positive. So as x values approach negative infinity, y values are approaching positive infinity. As x values are approaching positive infinity, y values are approaching positive infinity. So y values are doing the same thing on both sides. This is like a parabola. You just got something going on here in the middle. X-intercepts are at negative 1, 0, and 1, 0. Remember to find it without the graph. You just set these up equal to 0. So it's going to be negative 1 and positive 1. What happens at those x-intercepts? At both of the x-intercepts, it does what we call bounce. Okay, so it doesn't pass through, it doesn't curve and keep going, it bounces. So just put an arrow and bounce for both of those. This is the graph for number 2. So I would encourage you to pause the video on this one and see if you can fill in the answers to the questions and then come back. Okay, so I'm not going to go through every single one of these, but this is what your answer should have looked like. Okay, so for number 3, I would like for you to go ahead and go to Desmos, graph this one, and then come back and see if you got the graph right, and also check your answers. Okay, so this is what it should have looked like when you graphed it. The degree is 5, and the a value is negative. And what I'm noticing is that on the left of the graph, the y values are increasing, going towards positive infinity, and on the right side of the graph, they're decreasing, going toward negative infinity. At the x-intercepts, I noticed that the one with, I put them in order from here. So the x plus 1, x-intercept is negative 1, and it bounces. Just put a B there. And then at the 3, it also bounces. At the 6, it passes through. So you can put a P there. Okay, so I wonder if you're noticing anything yet about the bounce and the pass and the curve. Because I think we'll slow down a little bit and do this one together. The degree is 3 plus 2 plus 1, which is 6. As we approach the left side of the graph, the y values are increasing, which means they are heading towards positive infinity. As we go to the right side of the graph and the x values are approaching positive infinity, so are the y values approaching positive infinity. The x-intercepts are at negative 2, 0, 1, 0, and 4, 0. Let's look at what they do. Okay, so at the -2, 0, this is a curve. This looks weird because I changed the step on this. Do you see how this is like -165 right here? And this is 3 and -165. I had to change the step so I could get it all in. So this is a curve. So at -2, it curves. You can just put a C there if you want to. So what I'm noticing is that at this factor right here, at this root, it curves, okay? And then at the 1, this is a bounce. So this is a bounce at 1. So at the 1 with the x minus 1 squared, it bounces. And then at the 4, it passes. One thing I also want to make sure you understand is this being in factored form, again, means that we add the exponents together to get the degree. If this were in standard form, it would say something like, it would start out with 0.3 x to the 6th plus something x to the 5th plus something x to the 4th or whatever. So it would start out like this. The leading coefficient would be 0.3, and so that would be our a value, and then the degree of this function would be the 6, because when we multiplied all this out together, we would end up with a 6 exponent for the leading, the first term, the highest degree. So being in factored form means you add the exponents together. If it's in standard form, so if you got a bunch of this kind of stuff, whatever, then you look at the highest degree. You don't add them all together if it's in standard form. All of these have been in factored form. What I want you to do is numbers 5 and 6 on your notes. Before you come to class, I want you to graph those on Desmos, and I want you to answer these questions about those. Lastly, I want you to look at the top of page 5, and let's just talk about end behavior. Now, we've talked about end behavior all semester. We've done end behavior a lot. But what I just want to do is just kind of summarize here. So end behavior just states when the x value does this, the y value does that. Because I think this is worded very strangely, you can mark out this part on your, I think this is the bottom of page 4, and this is the top of page 5. Yeah, okay, so you can mark those things out. So end behavior is about the end of the graph. And of course, there really isn't an end of the graph if it has an arrow, but what we're looking at is those arrows. And so there are 3 possibilities that we could put. One of them is positive infinity, another is negative infinity, and the third one is a specific value, which we've looked at. That's an asymptote. So if it approaches a specific value, then that's either a vertical or a horizontal asymptote. Okay, so lastly, this is on page 5, the middle of page 5. These things got offline somehow. This was a Microsoft Word document, and it got offline, so you can really ignore all the as's, and then the odd should have been over here. So if you'll write in odd over here on the right. Let's talk about what these things look like. So if the a value is a positive number and the degree is even, then what the graph is going to do is on either side, let's draw a little sketch. No matter what goes on in the middle, I'm just going to draw arrows. So on this side, the arrow is going to go up and to the left. On this side, the arrow is going to go up and to the right. You might have all kinds of stuff going on in here, but what's going to end up happening if the a value is positive and it's an even degree, so if it's 2, 4, 6, 8, whatever, then the arrows at the ends are going to look like this. So what's the end behavior look like? Well, as x approaches negative infinity, y approaches positive infinity. And then on the right side, as x approaches positive infinity, y also approaches positive infinity. So invariably, so it could be a parabola, it could be all kinds of stuff going on in here, but these are what the arrows are going to do if the a value is positive and the degree is even. So if you go back and look at, let's see if we can find one. Here's one right here. Degree is 6, the a value was positive. Okay, what if the a value is negative? We don't have one like that. There may be one that you're going to do, but we don't have an even degree and a value negative. I bet you know, though, from your parabola. So if the a value is negative and the degree is even, anytime the degree is even, the y's are going to go the same way. Okay, so here's what your sketch will look like. I'll just draw like here, right here. Your arrows are going to go this way at the end. So again, you could have like all kinds of stuff going on here, but this is what your arrows are going to do. So as x approaches to the left, negative infinity, so that's the left of the graph, y will approach negative infinity. And the right side of the graph, y also approaches negative infinity. So what you might notice is if the degree is even, the y's do the same thing on both sides. Okay? So when the degree is odd, the arrows go in different directions on either side. Let me show you. If the a value is positive and the degree is odd, then on the right side, the arrow is going to go that way. And on the left side, it's going to go that way. And then if the degree is odd and it's negative, it's going to be opposite. So on the left side, it's like that, and on the right side, it's like that. A lot of times you'll see something drawn like this. So it'll look kind of like that. Okay, so let's talk about end behavior then. On this one, as x approaches negative infinity, so the left side of the graph, y also approaches negative infinity, and x approaches positive infinity, so these match. And then these are opposite. So before you go, I want to show you what your mastery check is going to look like, because I want you to understand that this right here, this p of x, that's y. Okay, so I want you to look at these. These are in standard form. So what that means is, that means you're going to look at the leading number, not the coefficient, the leading exponent. Okay, so this is an 8th degree polynomial function. So that means it is even and the a value is positive. So this right here is y, where it says p of x, that's just y. Okay, so this is y. So as x approaches positive infinity, y approaches positive infinity. X approaches negative infinity, y approaches positive infinity. So just understand that these are y's right here. Don't worry about it saying p of x. And also look at the first exponent, and then look at your a value. So your a value is positive and your degree is even because it's an 8. Okay, so that's what your mastery check is going to look like. I think there are 6 of them. Also remember, you will be expected to have numbers 5 and 6 from your notes done by class tomorrow.